All right, I'm Chris. This is
I'm
Brian.
I'm Brian.
We're going to talk about AgentCore, specifically runtime and security concepts. We gave this talk last week at New York Summit, and it was very well received, so we're excited to do it once again for you guys.
That talk was 60 minutes, so we have 20 minutes, so we're going to go in a very, really high speed. Yes, it's us.
Yep. Who are we? Yes.
Yep. Yes. Okay.
You saw us.
Kayland, yay, Kayland.
Yay. All right. What are we going to be talking about? We're going to level set a bit on AgentCore. Who's using AgentCore? You're familiar, and if you're probably, yeah, of course you are. But show of hands. I know what AgentCore is. Like, if you know what it is. Okay.
Okay, cool.
You know what it is. Okay.
Cool.
You know its capabilities. Maybe you're actively deploying workloads onto it. Anybody? Okay.
All right.
Oh, yeah.
Well, yeah.
I know you are.
Okay.
Yeah, we are. All right.
So the first question is, so what does AgentCore solve? So there's all this complexity of writing agentic software. You still have to worry about all the usual ilities, security, observability, integrity, all these things. And AgentCore, as much as we will rag on AWS a fair bit, removing undifferentiated heavy lifting is something that they're really quite good at. And so we started with Bedrock, and people were writing agents, and Amazon noticed that people were doing the same things over and over again. And then they did one of the things that they do really well is abstract that away to AgentCore.
So, components of AgentCore, as of time of this construction of this deck, this is what it exists. I think what's not on here is actually AgentCore Harness, which went GA recently. That's not on this. This was taken straight from the developer guide. You can see we've got built-in tools, browser, code interpreter, gateway, identity, super important for your workloads, memory, policy, payments. Yeah, what payments, I've got my opinions on that one. Registry, runtime, which is what we're going to be talking about, and just some of the assessment, observability, monitoring sort of stuff.
Right. Okay, so when you're working with agents, you typically go through a cycle of iterations. So you've got it working, and the support developer looks a little tired, but happy, and it's working. So then we move on, and then you're like, wow, I could do more stuff. I could have it write code for me. I could have it run in the browser. And with having write code for you, you can either have the agent run code that you've told it, or you can tell it, write me some code that does X, and then run it. Who thinks that is a really, really safe thing to do? Good answer. Okay. And then you're like, well, but my agent kind of stinks. It's repeating the same questions. It doesn't have memory. So let me add some memory. Okay, that's cool. And then you're like, well, what the heck is it doing? It's giving me answers I don't understand, or I don't know why it gave me that answer. So you need to have observability and then evaluability, but evaluability, yes, a new ability to see what's going on. Go ahead. And then once you start observing it, you notice that there are horrible things going on, and you're being attacked, and the attacks are succeeding. I'm looking at some of our security folks here. Okay, go ahead. So you have to add defenses, and then you have it. Only at that point are you ready for production. And our core developer looks a little happy. Probably could use a night's rest, maybe a shower. Hard
Looks
to
a
tell.
little dehydrated.
Right, exactly. So when we first started running agents, you had, all these various pieces, and none of these are especially hard, but you have to write them. You have to figure out, okay, where's my prompt store? Where's my session store? How do I get memory? How do I parse responses? None of these are incredibly hard, but they're not trivial either. That's how things were before AgentCore. Now, this slide we have to update because Chris looked and saw that Amazon made a change before lunch. So I'm going to tell you the slide and then tell you how it changed. But the question is, how do you control the execution environment when you're executing a tool in a runtime? And the answer is, you don't. The idea was, until 20 minutes ago, that you didn't do heavy computation in the tool. You had the agent make decisions and then hand off heavy computation to a tool, and you really couldn't change the size of the runtime. Like I said, 20 minutes ago, they just changed that.
Yeah, we just got the release of Lambda microVMs like this week, right? So that's what powers AgentCore Runtime, is Lambda microVM, and they just exposed in the Lambda console the microVM interface that you can now push your own images to. You can configure the runtime. A lot of stuff that you can't do in AgentCore, you can now do just on the runtime. And that runtime exposes HTTP endpoint for you to run queries against.
So how do agents run tools? One of the things that you really should know, at least a little bit, is about Nitro and the Firecracker VM. Amazon takes, for all its faults, takes security very, very seriously, and have put security into the hardware. So Nitro is on every one of their virtual machines, and basically you have one session, one micro VM. So every time you execute, you get a separate VM. There's no egress, there's no ingress from that. So when you have another session, there can't be crosstalk. You have the code interpreter. Your agent can basically run code. It can run a shell. Again, with the if you really think you want to say, hey, go write me a Python script that does X, and then run it without ever seeing the script. Yeah. Although go ahead and do it, but don't spend all your money on it. Then come to Kayland and we'll fix it for you.
Yes, we will. All right. As I mentioned before, AgentCore Harness. This has some good security benefits. Specifically, again, it runs on top of AgentCore Runtime, which we've established is Lambda microVMs under the hood. You get a persistent file system. You get a shell. Because it's a harness, you now can bake in all of your agents.md, your skills that you would use in something like Claude Code or Hero or Cursor, whatever harness you typically work with. But you can also borrow the other AgentCore constructs like identity and observability. So you can add a layer of authentication onto the harness and also be able to put it into CloudWatch and have observability and governance components surrounding that.
And one of the claims to fame for Harness is that it's adding yet another layer on top of things. So you can basically make two API calls and have an agent system running. There's the deploy and there's invoke. Mm-hmm. Although last week at the New York Summit they mentioned that there was the third call, and that may have just been a glitch in their talk, but we haven't figured out what the third call is. So you can right out of the box run a very opinionated sort of vanilla system that may well be enough for the beginning. You can then just add more parameters and fine tune it to your own liking. But it's actually not a bad place to start.
Mm-hmm. One other thing I like about Harness is you can also bring your own model too. So Bedrock models, you can do Anthropic, OpenAI, Gemini. They've made it model agnostic from that point as well.
Okay, and so then we talk about, and one of the things we I think we forgot to mention the whole Bedrock. The Bedrock user's guide is 1,220 pages. Has anyone read the whole thing? Well, we have. When I started reading it, I had dark hair.
I'm losing my dark hair.
And at New York Summit, we didn't have time to do it now, but we actually printed out a copy of the thing and dropped it on the floor, and nothing broke. So it's pretty extensive. But now we go into Gateway. Gateway is not a mandatory system, except for when it is, as with all Amazon things. And that if you're running Harness, you have to use Gateway. But Gateway acts as a control surface for your tools, your MCP servers, Lambdas, REST APIs, and so on. And it introduces a bunch of great security features. Now, if you're only running a few tools, Gateway may be overkill, but it lets you do a bunch of things like semantic search for your tools, which may or may not be a good thing. But
yep.
So basically, the request flow is an agent, one of your user agents makes a call to the gateway. You can intercept the requests with a Lambda and do anything you want with it. You can intercept the response and do anything you want with it, and then makes the calls out to the targets. This can be for things like the prototypical thing is, don't allow refunds over $500, don't expose personal information. One of the things you really need to decide is, do you want to block it from seeing the information at all? Or do you want to let it go through and retrieve information and then block it afterwards? I believe in defense in depth, you should do both. But the request interceptor also lets you do things more sophisticated. Like rather than just say nothing over $500, you could have an interceptor that looked at the customer's history and said, well, this customer is having a lot of refund requests. Maybe we want to bump that up to a user agent. Human. Yes, human.
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 Yes,
Yeah. Sorry, I forgot. What do we call it? Where are human?
A human.
Wetware. Yes.
Yeah. Yeah, we'll talk about it later in the conversation, but we're highlighting request interceptors and response interceptors here. But another option here is using policy, which is more deterministic policy-based Amazon verified permissions under the hood, where the request gets blocked at the gateway layer if you're using policy. Whereas your request interceptors, if you want to do custom code, like you're wanting to transform a header from the incoming request to the header on the outgoing request in a certain blob on the JSON, you can do that so that it translates to your downstream targets. We'll talk about that in upcoming slides. Okay, now the actual production system. Here's a demo architecture. It's not really a demo because it's actual like real life production. Like this is powering stuff at Calent. What does this look like? Essentially, we have a web app. We have different access points, either web app, MCP client, in this case, Claude Desktop, ChatGPT Desktop, or web, that are hooked up and are calling an MCP server. Okay, mcp.yourwebsite.com. Okay, there's the MCP server is running on top of AgentCore Runtime. Okay, there's some built-in baked-in tools to that runtime that basically route to like internal tooling, whether that be knowledge bases, enterprise data. I call these things the enterprise knowledge corpus, EKC, the term I branded for it. Maybe it has a couple of routes to an identity service, or it holds some information in a database. Then we have the gateway, and behind the gateway is all the third-party integrations. Okay, in this case, we have some HTML publishing stuff that goes over here. We've got third-party integrations to maybe Google Workspace, Notion, Slack, and GitHub. And then we have maybe you have an agent skills registry that's also backed in GitHub that you need to have authentication layers in front of that. So that's kind of the model, the demo architecture of how it all works. User identities are stored in Cognito. The external IDP is something that could be like Rippling or Entra ID or Okta. Whatever your external IDP, doesn't really matter. It integrates the same. So the first hop in the process, and this is at the runtime level, we're building this on top of FastMCP. Is anybody familiar with FastMCP? Anybody familiar with FastAPI? FastAPI it's like FastMCP is a flavor of FastAPI. It uses Starlet under the hood like FastAPI does. And what we do, we have this entry point here on the runtime server and a couple of middlewares that help us strip paths off of the incoming request, but also do some authentication capture. So what happens is we have a JWT that's vended from Cognito when the IDP is when we have the incoming inbound authentication. Okay, that JWT, the middleware will intercept that and then do that first level of authentication. Like, can this user even access, right? Is your token expired? Do they need to sign in again? That sort of stuff. So we stop it right here at this initial middleware layer. If we work further down, we propagate the local tools and then apply any tool transforms that need to happen for the client, like in Claude Desktop. When you get human readable tool names, all of that happens here. This allows us to add tools to the underlying code, and we don't have to expose that to the runtime. It's just pulled in at runtime when the packages are instantiated here. So we dive into the middleware layer, and what happens is the auth token gets put into context. Okay, that context travels through each hop in the chain so that we don't have to re-authenticate every single time. Okay, the validation happens at this layer. We pull off the token, we verify everything's good, and then we send the call to the next spot. Next, the agent can call a platform identity service. It can initiate OAuth. In this case, we're calling an external identity service, okay, that will populate the JWT with any other scopes or any other matter that needs to be put into the token, and forwards it along the next hop. Next, the tools that are backed by the Lambda targets get proxied through the AgentCore Gateway. Okay, in this case, we're using actually an HTTPX method here. This is not native to AgentCore, where we inject the authentication into the request that goes through the gateway and then the Lambda interceptor. Okay, this factory in HTTPX will add that to the outbound request, what you see in the very bottom of the example. Okay, the next thing, the gateway interceptor. Okay, as we discussed in a previous slide, we have the request interceptors and the response interceptors. The AgentCore Gateway doesn't automatically propagate those headers through. It's just the middleman. Okay, when you want to add the custom code, that's where your interceptor comes in. Okay, in this case, it's just a simple Lambda handler, similar to like Cognito custom authorizers. Anything that a Lambda goes and does as a response to an event, it's a similar pattern here. So what we're doing in this case is we're checking the request headers, we're grabbing the authorization in this case that JWT that was passed from the previous hop in the chain, and we're transforming that request and adding the auth header into the next request in the chain, right? So we're basically passing it along through the custom code into the next boundary. Okay, next, the Lambda target. So this is, if we back up a few slides, so the Lambda target in this case, the runtime, the MCP server was hop 0 and 1. Then we had the gateway where we transfer the token, and now we're on the outbound side where we're either calling like a downstream REST API, another Lambda function, other MCP servers. So what happens next? The Lambda target receives that JWT, okay? And now what you're going to do is you're doing another layer of authentication. In this case, we are populating the user's tools that they have access to. Okay, all of it is on the token. Okay, so if you look in the second to last line from the bottom, we populate the tool names and we also give the JWT token. Okay, so that we can say, do they have access to these tools? Do they not have access to these tools? Now, that JWT is passed into the downstream tool calls, which is this part. So now we do credential exchange. So in this case, a part of this architecture is that we give our users the ability to call out to Jira. They can go search GitHub all through an agent, through Claude Desktop, Web, or Claude Code. Okay, and what happens is anything that the user has access to do, the user identity, the agent will be able to do, or the coding assistant will be able to do. Okay, in this case, the example we give is being able to search issues in Jira. Okay, so that JWT that came all the way through each hop in the chain is now used to go authenticate to Jira. Okay, and then that will exchange it for an access token, and now the agentic process can then operate as it was the user, create Jira issues, read Jira issues, any sort of access that user has in Jira, now that process can do.
And if you think of what could go wrong if you didn't have all these layers of security in Jira, one of the experiments we did ages ago was say, hey, I've got a lot, it's coming to the end of the sprint and I still have a lot of open tickets. Can you help me? And I said, sure, I closed all your tickets for you. So you don't want to let it do that.
Yep. And I will call out this. We're using a custom identity solution. We're not using AgentCore identity. The reason why is because AgentCore identity is simply workload identity. So what can the agent do, right? Give it permissions to act and call out to services that are not on behalf of the user. What we're doing is we're basically proxying the user's permissions through the chain so that a surface like Claude Code could then create tickets, update tickets, go fetch code from GitHub, that sort of stuff.
So Gateway has all kinds of security features, as Chris has been talking about. We have the OAuth authorization. We can do translation back and forth of the headers and the bodies. We can combine multiple API calls into single things. We can do the credential exchange, which we just talked about. I'm going to skip semantic tool selection just for a sec. We can do infrastructure management. But going back to the semantic tool selection, you can say, hey, go call me a tool that does X. And the question is this a good idea? We've gone through the evolution of what is best practice in that it used to be, have a monolithic, we've gone through so many times, I can't remember where we started, but it's like, should you have one monolithic agent that can call any number of tools? Should you have individual agents that can call specific tools? If you have enough tools that you have to use semantic search to find the right tool, maybe you have too many tools. And English is a very ambiguous language, so it can be very hard to do this. So our own thinking, or at least my thinking, is modest number of tools, modest number of agents reduces the potential ambiguity.
Policy versus gateway. We talked about this at near the start. Okay, this is a more of an architectural trade-off, right? When would you want to use policy versus when you would want to use a gateway interceptor? What we illustrated was the use case of an interceptor, because we were doing a lot of custom code. We were transferring JWTs onto request headers. We were reading them off of headers. Whereas something like a customer service agent or a refund agent that may be in charge of authorizing refunds, you need more deterministic policy enforcement that is basically like yes, no, black and white. They can or can't do that.
Right. Policy is very deterministic. The interceptors, you can do anything, which means you can do anything.
And of course, with great power comes responsibility, comes great responsibility. This is our security speech of you are, as a user of AWS, you are responsible for security in the cloud, not security of the cloud. That's Amazon's responsibility. So I am what your agents can and can't do, what your users can and can't do. That's your responsibility, not AWS's responsibility.
Right. And so hopefully to this audience, we don't have to stress this so much, but we have run into people who said, well, I don't have to worry about data security because my data is in Amazon, right? It's like, no, I don't have to worry about security because I'm using AgentCore, or I'm using agents. No, all the entities still matter, and in fact, they probably matter more. And one of the discussions that's going on behind the scenes is a lot of companies are trying to hire agentic engineers. I think that is the wrong approach. I think you should be hiring engineers who have experience in network programming, distributed programming, because agents are just a special case of distributed programming. Remember in distributed programming, every call could fail, every call could time out. It could time out and then give you an answer. So there's the whole item potency. All of those concerns are even more important now with agents, especially because the agents can do real things and they have agency.
Mm-hmm.
And I have to say, just as one joke, because there was a contact center call or talk earlier. Remember in the contact center early days where you'd want to speak to a human and you'd say, agent, agent, agent. Now you're already talking to an agent, so you should start saying, human, human, human.
Yeah. Yes.
So.
All right.
That's it.
That's it. Thank you.